Okay, welcome back. So yesterday we learned about just coming up with the correct notation if we're trying to find just the domain on a number line. Today we're going to put it together and we're going to find the domain and the range of graphs. And so we have to keep in mind that when we're talking about domain and range on an actual coordinate plane, we have two things happening. And what we have to do is try to separate what's happening. We're going to look at x first, and then we're going to look at y. So quick review, the domain, remember, is a set of all x values, and the range is a set of all y values. Now I want you to think, the domain is going from left to right on the coordinate plane, and the range is going up and down on the coordinate plane. And so now we're going to separate them, okay? So if you go ahead and take a look at number one's pretty simple. You have three ordered pairs. You have this point, and this point. Now, one way you could do this is you could, down below or next to these points, write what these ordered pairs are. But I actually find it easier to just first, we're going to look at the x-axis, right? And if I were to take these points and bring them down to the x-axis, where would they end up? So if you look, B would end up at -2, C would end up at 2, and A would end up at 4. So since those are their x values, then the domain is going to be x such that x equals -2, 2, and 4. All right, so now the range. The range is our set of y values. So now we're going to take a look at these points, and we're going to go from least to greatest. Down here, this is going to have the least y value because it's at the bottom, right? You go down. If I were to slide this point over to the y value, it hits at -4. And if I were to slide this point over to the y-axis, it hits at -2. And if I were to slide this point over to the y-axis, it hits at 6. So the range is -4, -2, and 6. So I'm going to write y such that y equals -4, -2, and 6. And of course, if you're having a hard time sliding the points onto the y-axis or onto the x-axis, again, you could just write the ordered pairs of each of them and then just list the x and the y values. And then the question, is this a function? Well, you're asking, does it pass the vertical line test? And the answer to this is yes, because these points do not hit the same vertical line. So that one was pretty simple. Whenever you have actual ordered pairs, your domain, you just list it with numbers. Now, if you get over to number two is a little bit trickier because we have a line, right? And this line, all of the fractions and decimals in between all of these ordered pairs that this line goes through are also solutions. So if I'm asking about the domain, I'm asking you to imagine that this line is on the x-axis. And what points does this line hit on the x-axis? Well, if you look, if I shaded in the entire x-axis, that would be this line, right? This line, if I brought it down to the x-axis, this line is going to hit all of the x values. So the domain here is x such that x equals all real numbers. And remember, all real numbers is the big R symbol with the extra line next to it. And one thing, if I started just imagining, if you're confused by why it's all real numbers, if you just started imagining all the x values, like this ordered pair would be 0, 2. The x value would be 0. This ordered pair would be 1, 3, 0, 3, 2, 3, 3, 3, 4, 3. What's happening is I'm just hitting every single x value. Now the range is the y-axis. So if I am imagining what points or point this line hits on the y-axis, if I were to squeeze this line in, it's only going to hit right there, right? Like this line does not hit any other place on the y-axis. So this would be y such that y equals 3. And don't forget to put it into set notation. And is this a function? Yes, it passes the vertical line test. Okay, let's do a few more. All right, so number 3. Number 3 is just a straight line, and this straight line has a slope, a positive slope, and because it has arrows, it's going to keep going on in both directions. So if you imagine the domain, if you take this line and imagine putting it on the x-axis, again, this line is going to hit every single x value in both directions, right? This would be 0 as an x value. Right here would be 1. Right here would be 2 and 3 and 4. And we could even go backwards. 0, -1, -2, -3. So you can also just imagine this being flattened out and brought down to the x-axis. So again, this one would be x such that x is all real numbers. And put that in set notation. Now imagine your y-axis. The range is the y-axis. If I took this line, keep in mind it has arrows, it's going on in both directions. If I took this line and put it on the y-axis, it would cover the entire y-axis. So again, this would be all real numbers. So this would be y such that y is all real numbers again. And is this a function? Yes, because it passes the vertical line test. All right, let's take a look at the next one. Now the next one is a ray. It's a ray going in one direction, right? That's what a ray is. It's a line going in one direction. So it has a stopping point. So this point right here, that ordered pair, it's pretty important. That point, I'm going to write what the ordered pair to that is. It is 3, -4. Now, for the domain, let's just look at the domain here. So the domain for this, if I take this ray and I pop this point up to here, it hits the x-axis at 3, which is what we put here, right? And then this line is going to the left. So if you think about all of the x values to the left of 3, well, that's where x is less than or equal to 3, because that's a closed dot. The domain here would be x is less than or equal to 3. So we're going to say x such that x less than or equal to 3. All right, now the range, if you look at the range now we're looking at the y-axis. So if I take this point and I slide it over to the y-axis, well, that's hitting at -4, right? And then this line is shooting up, right? If I slid this over, then the rest of this line would be going up the y-axis. So these y values are going to be everything greater than or equal to -4, because we're going up. So the range here would be written as y such that y is greater than or equal to -4. And is this a function? Yes, it passes the vertical line test. Okay, now we're going to keep going. I'm going to try to hit every kind of possible question you might be asked like this. Then, so number 5 is really similar to number 4, except now this point right here is an open dot, and this open dot is shooting to the right and down. So when I'm looking at the domain, I'm separating the x and the y, right? Domain is x, so I take this point and I bring it down to the x-axis, and that point hits the x-axis at -1, -2, -3, -4, -5. And so when I bring it down here, the rest of the line is going to the right of that point. Well, to the right of that point is everything greater than. But now since it's an open dot, that means that -5 is not actually considered a point. So this is going to be x such that x is greater than -5. Now the y-axis, for the range, you're going to take this point and you're going to slide it over to the y. And what is that point on the y-axis? Well, that goes up 1, 2, 3, 4, 5, 6, 7, 8. So that is the point 8 on the y-axis. So this is 8, and then this line is shooting down. So all the points down are below 8. So this would be y such that y is less than 8. Is this a function? Yes. It passes the vertical line test. All right, let's take a look at the next one. So all of these are going to be a little bit different, okay? And once we do more of them, you'll start to see what type of notation I'm going to end up using. All right, now, this one's a little bit tricky. This is called a parabola. This guy right here continues going in this direction, but it gets wider and wider and wider and wider as it goes. So if I were to flatten this curve out onto the x-axis, this it would shoot in both directions. So this guy is going to hit every single x value. So this one is going to be x such that x is all real numbers. It's hitting every single x value. The range, however, doesn't hit every single x value. The range, you're going to be looking at the y-axis. And so if I were to squeeze this whole thing onto the y-axis, it would not go below this point, but it would be shooting up here. So the smallest range is going to be this point at -3, but it's shooting up. So the range is going to be everything larger than -3. So we're going to say that y such that y is greater than or equal to -3. And again, this is a function because it passes the vertical line test. So number 7 has two things going on. It's got this part of the graph and it's got this part of the graph. So this is like one of our compound inequalities. So let's take the least part of the graph first because it's good to go from least to greatest. So this is the least part of the graph if we're looking at just the x-axis. So this point hits the x-axis at -1, and if you think about sliding this up onto the x-axis, it's shooting to the left. So this is going to be x is less than or equal to -1. But this part, and it's going to say or because they're separated, there's a space here. This is going to be or x is greater than or equal to 2 because it's shooting to the right. So it's hitting all of the x values that are bigger. So my domain is going to be x such that x is less than or equal to -1 or x is greater than or equal to 2. Now the y, let's start down here because that's the smallest. If I shoot this y value over onto the y-axis, well that is the point 0, 0, right? So it hits the y-axis at 0 and the line is going down. So it's going everything below 0. And then this point, if I slide it over, is going to be everything above 2. So this is going to be y such that y is less than or equal to 0 or y is greater than or equal to 2. And yes, this is also a function. So number 8. Number 8 is another compound inequality. So let's take a look at this. If I take this, so this is a line segment, so it starts here and it stops here. So if I'm looking at the domain, if I take this point and I slide it down, it hits -3. And if I take this point and I slide it down, it hits 2. And it's covering everything in between -3 and 2. So this is an and notation, or what I like to say an in-between notation. So the way I'm going to start this is I'm going to go ahead and say x such that. And I'm not going to start the inequality with x is greater than or less than anything because x is actually in between -3 and +2. So that would be -3 is less than or equal to x, which is less than or equal to 2. So the x, if you look, the x is actually in the middle of -3 and 2. And when you are putting these numbers in order from least to greatest, these symbols will always be less than or equal to symbols. All right, so let's take a look now at the range. So the range is going to be the same notation. And so we're going to go from the smallest point on the y-axis. If I take this point and put it on the y-axis, it hits at 1. If I take this point and put it on the y-axis, it hits at 4. So y is actually in between. Sometimes I like to write it this. Y is in between 1 and 4. And then I'm going to put less than or equal to symbols in here because I have closed dots. And then I'll put my y such that at the beginning. So sometimes it helps to just write the two numbers that y is in between and then add the symbols in later. Whatever makes the most sense to you. And yes, again, function. Okay, so now the next two are shapes. And really, if you haven't caught on, what we're really trying to do is we're just trying to figure out like the picture or the graph that you have, how much, when I ask for the domain, how much of the x-axis is this picture taking up? And when I'm asking for the range, I'm asking how much of the y-axis is this picture taking up, which is why I'm trying to get you to squash it onto the x-axis or onto the y-axis, depending on if we're talking about domain and range. So if I'm talking about the domain right now, if I take this whole picture, it has the top part goes down here, and then the bottom part also can get squashed up. And so it's hitting the x-axis, it's hitting everything from this x value at -3 all the way over to this x-axis at +4. So this would be that x is in between -3 and +4. And I'm going to put less than or equal to symbols in there. I'm going to start it off with x such that and put it in set notation. Okay? So now the y, if you're looking at the picture, the y-axis, how much of the y-axis does this take? Well, the graph never goes below this point on the y-axis, and it never goes above this point. So it's covering all the y values between this point of -3 all the way up to this point at +2. So y is in between -3 and 2. So I'm going to write y such that -3 is less than or equal to y, which is less than or equal to 2. And this one is not a function. It's not a function because if I put a vertical line in here, I'm going to hit points more than once. In fact, there's a vertical line right here. Okay, the next one, another shape. So the domain is how much of the x-axis does this picture take up? So we're looking at the x-axis, right? So this picture starts here, ends here. So go with this point. This point goes down on the x-axis at 0, all the way over to here. This goes down at 5. So this graph is going to cover all of the points between 0 and 5. So it looks like this. X such that 0 is less than or equal to x, which is less than or equal to 5. And now the range. Looking at the range, how much of the y-axis does it take? So this, the bottom, starts here at 1, and this whole graph goes all the way up to 4. And it never goes below 1 or above 4, so it's covering everything between 1 and 4. So that would be y such that 1 is less than or equal to y, which is less than or equal to 4. And again, this is not a function because it doesn't pass the vertical line test. All right, let's do 2 more together. All right, last 2 we're going to do together are equations. And don't let equations fool you, right? So this equation right here, y equals 1/4 x minus 5, well, that's a linear equation. It's in slope-intercept form. It's going to graph a line, right? But if you're having trouble deciding what the domain and range are, you could just sketch a graph real fast to remind yourself of what this looks like, okay? So the y-intercept is -5, so let's say that's -5 down there. And the slope is 1/4, so if I rise 1, run 4, I'm going to have a point over here. I could do it again. I could go down 1 to the left 4. And what I have is a line right here. Now, all lines, as long as they're not horizontal or vertical, all lines are going to have a domain and range that are all real numbers. So this one, we're going to say x such that x is all real numbers, and the y value is also all real numbers. So all equations in slope-intercept form, the domain and range, they're going to be all real numbers, both of them. And yes, they're functions. We talked about that the other day. Any equation that has an x and a y is going to be a function if it's linear. All right, so now let's look at number 12. Number 12, x equals 5. Well, what is that equation? Well, that equation's a vertical line, right? That's a vertical line going through 5, right? So if I go 1, 2, 3, 4, 5, sorry, my little tick marks didn't happen there. That's the vertical line going through 5. Well, the domain, the only value that's x that this is going to hit is 5. It's never going to hit any other x value. So this domain is just x such that x equals 5. The range, however, if I slide this over to the y-axis, it's going to hit every y value. So the range is y such that y is all real numbers. And no, this is not a function because vertical lines are not functions. All right, go ahead and try the rest on your own, and you may want to check back to Blackboard to see if I've put up an answer key to the back section. Good luck!